Lab 7, question number 6. It says consider a random sample denoted x1, x2, and x3 to be sampled from a population with unknown mean mu, and unknown variance sigma squared. Recall an intuitive estimator for sigma square in the case of n is equal to 3. We said that sigma hat square is equal to 1 over 3 sum of xi minus x bar squared, which when you expand it, you can write it as it's equal to 1 over 3 sum of xi squared minus x bar squared. Now, where the sample mean estimator is x bar, and we know that x bar is equal to x1 plus x2 plus x3 in the case that we have got 3 random variables divided by 3. In this question, you will be stepped through a proof that expectation of sigma hat square is not equal to sigma square. Okay, you remember that in order for an estimator to be unbiased, expectation of that estimator should be equal to this parameter. Now, in here, we want to say that the expectation of the estimator for sigma square is biased. Okay, so what we need to do here, we say that, okay, the expected square distance from the mean is the sigma hat square. Now, the first part, we know that sigma square, we knew, was equal to expected xi squared minus mu squared. From here, we can say that the expectation of xi squared would be equal to sigma squared plus mu squared. We just take this one to the other side. Okay? So let's remember this one. In the other hand, expectation of xi multiplied by xj is equal to expectation of xi times expectation of xj with the condition that xi and xj are independent. So we know that expectation of xi is mu and expectation of xj is mu. So expectation of xi times xj would be mu squared. Now we want to talk about expectation of x bar squared. So expectation of x bar squared is equal to expectation of, so what would be x bar? It would be x1 plus x2 plus x3 when we have got 3 random variables. And we square it, and actually x1 plus x2 plus x3 divided by 3. The whole lot we square it. All right? So we want to see what does that one equal to. So that one would be, we said that, so we have got expectation of x bar squared is equal to, now we say that it is expectation of x1 plus x2 plus x3 divided by 3, the whole lot squared. Now we can say this one is equal to, we take 3 squared out of the expectation because it is a constant, so we can write it as 1/9 expectation of x1 plus x2 plus x3 squared. That one is equal to 1/9, okay, expectation of x1 squared plus x2 squared plus x3 squared plus 2x1 x2 plus 2x1 x3 plus 2x2 x3. All right. Now, we said that in the previous slide, we said that we know that expectation of xi squared is sigma squared plus mu squared. So expectation of x1 squared is sigma squared plus mu squared, and the same for expectation of x2 squared and expectation of x3 squared. On the other hand, we know that expectation of x1, x2 would be mu squared. All right? So in here, expectation of x1 squared, we say it's equal to 1/9. Expectation of x1 squared would be sigma squared plus mu squared. This is sigma squared plus mu squared, sigma squared plus mu squared. So we will have 3 times sigma squared plus mu squared, because expectation of each one of these is sigma squared plus mu squared. Then plus expectation of x1, x2 is mu squared. This is mu squared, this is mu squared. So we have got 2 mu squared plus 2 mu squared plus 2 mu squared. So it would be 6 mu squared. So that one will be equal to 1/9 3 sigma squared plus 3 mu squared plus 6 mu squared. And that one is equal to 3 mu squared plus 6 mu squared is 9 mu squared. So it would be 1/9 3 sigma squared plus 9 mu squared, which that one will be equal to 1/3 sigma squared plus mu squared. So the whole lot of this slide is just expectation of x bar squared will be equal to this one. This is equal to expectation of x bar squared. Okay? Now, the next thing is, we said that sigma hat squared was equal to 1 over 3 sum of xi squared minus x bar squared. So we want to prove that what would be the expectation of sigma hat squared. So we want get the expectation of this one. We did get the expectation of x bar squared in this slide. So we have to get expectation of 1 over 3 sum of xi squared. Okay? Now, so we have sigma hat squared, expectation of sigma hat squared is equal to 1 over 3 sum of xi squared minus x bar squared, expectation of this bit. Yeah? So it will be equal to 1 over 3 expectation of sum of xi squared minus expectation of x bar squared. Now, we have to get what is this one. So, we say that 1 over 3 expectation of x1 squared plus x2 squared plus x3 squared will be equal to 1 over 3 and then expectation of x1 squared. You remember here we say that expectation of xi squared was equal to sigma squared plus mu squared. So in here, expectation of x1 squared is equal to sigma squared plus mu squared. Expectation of this and this is the same. So it becomes 1 over 3 times 3 sigma squared plus mu squared. Okay, so this cancels out, so we are left with sigma squared plus mu squared for that bit. 1 over 3 expectation of sigma xi squared. Okay, so now in here we had expectation of x bar squared is equal to this, and here we had expectation of 1 over 3 expectation of sum of xi squared is equal to this one. So expectation of sigma hat squared would be equal to expectation 1 over 3 expectation of sum of xi squared is sigma squared plus mu squared minus expectation of x bar squared. We got it as expectation of x bar squared is 1 over 3 sigma squared plus mu squared. So minus sigma squared over 3 plus mu squared, and that will be equal to sigma squared minus sigma squared over 3 gives me 2 over 3 sigma squared, and plus mu squared cancels with minus mu squared. So here we can see that expectation of sigma hat square is equal to 2/3 sigma square. Therefore, expectation of sigma hat square is not equal to sigma square. So we say that the estimator for sigma square is not an unbiased estimator, it's a biased estimator. Then in the part okay, so all of these I talked about is part A to F of question 7 in lab 7. Question 6 in lab 7. Now, in part G, it says that for the general n, S square sample variance is equal to n sigma hat squared divided by n minus 1. Now, in this part of the question, it says use this with n is equal to 3 to show that S square is an unbiased estimator of sigma square. Okay, so we say that here S square. What do we want to do? We want to get the expectation of S square when n is equal to 3. So it would be 3 divided by 2 and expectation of sigma hat square. But we got expectation of sigma hat square in here. We said that expectation of sigma hat square is equal to 2/3 sigma square. So expectation of sigma hat square, we put it as, so we have 3/2. Instead of this, we put 2/3 sigma square. So these cancels out. So expectation of S square is equal to sigma hat square. That's why we say for an unbiased estimator for the variance, we say it would be equal to sum of xi minus x bar squared over n minus 1. That is an unbiased estimator, which is the formula for S square sample variance. Okay, so that will conclude our question number 6 for lab 7. Thank you.